Welcome back, YouTubers. Chas from P&W Electronics. Today, it's PIC versus Arduino in under 30 seconds. It's not really a fair comparison. To be honest with you, I feel a little dirty for doing this video because it's kind of like GM versus Chevy Malibu. It's not quite the same. Matter of fact, the micros are made by the same company, Microchip Technologies. But here it is anyways. It's PIC. PIC wins. For me. It really depends what you're using these for. The Arduino is great if you're new to the hobby, if you don't have any micro experience, if you're doing like one-off, hobbyist sort of grade things. This is a great tool to get you going really, really quick. I use them myself. PIC. Are you trying to monetize a product? Trying to do something in large scale? Are you looking for power savings, ultra low power, something along those, some flexibility? It's the PIC. And that's it. I mean, really, it just depends what you need. However, if you're interested in some more details, hang out for a second. I'll get into it in just a second. Okay, before you write any comments, I know I didn't give you much of an answer in 30 seconds, nor did I really in a minute, but these are two totally different things. The Arduino is a development system. It's a company that developed some boards. There's a ton of clones out there, and they have a nice, easy to use IDE that we'll go through, an integrated development environment. The nicety of the Arduinos is they have a nice standard pinout, and you can throw on all these shields, and some of them are just proto boards, and some of them are motor drivers, and some have they run 3D printers, or all sorts of stuff out there. Tons of stuff of shields that you can purchase to place on here, and they have a variety of sizes too. They have the Uno, which is certainly the most popular version, and if you buy any of these multi-pack kits with sensors and everything, that's commonly what's put in there. The Mega, I actually like using the Mega a lot. I use the Mega in my robotics. This is kind of a cool little snap-on where you throw the Mega upside down and plug it in, and then it's DIN rail mount. Some bigger ones, Nanos, some other smaller boards made from Adafruit and SparkFun and a bunch of other vendors. There are a lot of parts that you can program with IDE that are not considered, Arduino. The ESP8266, not Arduino. Great product, but ATtinies, the 85 and so on. Fun, useful tools, not technically Arduino. So the Arduino is a development system. It's not actually the microcontroller itself. The microcontroller is a Atmel ATmega 328P in this case. And this is the Atmel chips made by a company called Microchip. Well, Microchip makes PICs as well. And the PICs are a line of microcontrollers. This is a PIC. It's just a little well, this one's SOIC. This one happens to be an 8-bit in this 16F line. And this is just chips. Now, they have a ton of development boards out there. Many more than the Arduino, I would say. Some, specialty made ones from people. Microelectronica or Micro, they have a whole line of development tools they put out there, and they have a kind of a standardized bus that they've developed as well. This one happens to be the PIC clicker with a GPS board. And then Microchip, or Microchips picked up that microbus themselves and started putting on their development boards as well. Some older boards, look like this is an OLMX board, and then an older Microchip 8-bit board. But many of them also have that micro bus. Now, let's try to normalize these. Let's stick with the Uno or even the Mega, which are 8-bit RISC processors, the PICs. Now the PICs have some 16F series and some 18F series 8-bit microcontrollers. And we'll go through this, but really the differences I want to outline include the toolchain IDE. There's some big differences there. The types of development boards that are out there, the support that you can get, if you're using the Arduino line versus the PIC micros, and finally the integrated peripherals, which are found within the actual microcontrollers themselves, the actual chips. And I think once we review those 4 items, I think you could make an educated choice for yourself on what the best tool is for you. Is it the Arduino or the Atmel micros, or is it the PIC and its development toolchain? Okay, we're going to start with the differences in toolchain. I'm going to start here with the Arduino IDE. Pretty basic. This is an application I wrote earlier to measure temperature, drops it to a serial port. So I have a couple of menu items up here on top. Lines are numbered. And go ahead and they have some built-in examples, which are really nice. I'm going to just open up a new sketch, which is kind of synonymous with project. So I'm going to go down to examples. I'm going to pick kind of one of the built-in really easy ones. It's called Blink. It's just turns on and off the onboard LED on their Arduino. Let you know it's alive. So there we are, setting the pin mode, turning it on, delaying, turn off, delaying. I'm going to go ahead and compile it. And then since I've got it compiled, I'm going to hit the little arrow button. I'm going to try to upload it to the board. It's going to fail because I'm actually compiling to the wrong type of board. So I'm going to go over here to Tools, down to Board, select my Arduino Uno, which is the board I'm actually connected to with my computer. Make sure I'm on the right COM port in the ports. I am. I'm just going to grab the board info, make sure I'm looking at the right board. I am. I'm going to go ahead and recompile then. And then time to upload. Alright, if you could see it, you'd see my board was blinking now, and that's really all that's to it. A couple menu items. Now, Arduino has a bunch of libraries that make adding special sensors and stuff easy, and this is the library manager. Say I wanted to grab a Max chip, and I just happen to use this Max chip here. I can just click install and install a library. Ask me if I want to install some associated libraries. I do. And I'm done. Now, when you install a library, it adds, if it has it, examples into your examples directory. So I'm going to scroll down to there's my new library. I'm going to grab an example, scroll down, and it kind of says, oh, there's my library. It gives you an example of how to use this thing. If you had this hooked up right, you could, in theory, compile it, download it, and it would work. Of course, I don't in this case, but ready to go, ready to compile. Now, I went and installed or uploaded my program that I was writing. This measures temp. Now, one of the things I do not like about Arduinos is its ADD converter. It's only 10-bit. So in this case, you look at the temp values, 513 to 514. You see a degree of change in just one click, since this is 0 to 1024. That's a 10-bit number. The resolution isn't there as much as I want to be. Now, I could have maybe written or added this sensor onto an I2C sensor, but I used the ADD converter. And I think this is one of the big selling factors of being able to use a different micro, is the 10-bit ADDs don't quite work out in some cases. But again, great beginner tool. All this, that's an example. All I'm doing is grabbing the sensor value, dropping it into the serial port so you can see it. That tool is in a serial monitor. It's a really handy tool for looking at the data or troubleshooting. All right, on to Microchip, the MP Lab ID. Here I'm going to start a new project. I'm going to go select a 8-bit PIC18F micro, scroll down, find the microcontroller I want, click next. No debugger. If I was going to use anything, I'd probably use some Curiosity board, so I'd probably click next here. I have to select what kind of compiler I want. I want a C compiler. There's also a assembler down below. Some of my older blogs use assembler. Give it a name, and click finish. So there we are. There's my project. Nothing in the files yet. I don't have a main.c yet, but now I'm going to go ahead and create a main.c. It's kind of my source code file. And there's nothing there. I mean, that's a basic application. I can go ahead and, since I want to configure this, I need to add a plugin. Now they have a very handy plugin called the MP Lab Code Configurator. Code Configurator kind of makes setting up these PICs much easier, especially as you dance from series to series. So I'm going to go ahead and install this, speed this up because it takes a long, well, on my computer it takes quite a while to install this. Alright, there we are. Now to launch the Code Configurator, there's our application that we started already. I'm just going to build it. Builds just fine with nothing in it except for the framework. Now to start the Code Configurator, up on top kind of have the, well, sitting there in the middle under System Module, we have oscillator setup. I'm going to use internal RC oscillator. Down below is the Watchdog, choosing 4 megahertz. Down below that's my pin manager, which I'll review. Selected low voltage programming enable. So on the left is kind of similar. This is our device resources. I can add a UART here, and then it allows me to configure it. Select my baud rate, and then all the other properties. Obviously, a lot more in depth than our Arduino. You can really get into the nitty gritty of the registers. On some micros, you can, with PPS, you can stick that port just about anywhere you want. A couple obvious ones are, like reset and stuff. You can't stick it there, but you can move them around. You lock in your inputs and outputs down there with the pin manager. I'm going to go ahead and add a ADC. Same sort of thing. A lot of options, library choices. This particular package, I don't remember what I'm guessing it's a 10-bit A to D, but you can definitely get 12-bit analog to digital converters. All right, now that we've gotten kind of 2 modules selected, again, playing with registers, we can go and generate our framework code. Right now, because I created a main.c already, it's kind of asking me if I want to synchronize them. If I had not created that file manually, I wouldn't have had to worry about that. That's all right. So we're all generated. I'm going to go and open up my main.c file again. That's where I stick all my main code. And then over there on the left, you see all the generated files from the configurator. It generates a bunch of commented items, such as your interrupts. If you want some examples of what libraries that we added are, you can scroll through these the MCC generated files and look at some examples. So there's an example of the UART code. Again, another example. Here's an example of the, using a portion of the ADC. It's a lot more work, but it's also a lot more configurable. So let's go ahead and see if this will compile as generated. I kind of should. It did. we're going to download it, we would go in and build the main. We're just doing a review of the menus here, kind of cruising through. A lot of options in there. I'm not going to go through them all. There's a ton of good resources. This is where we would make and program our device right here. We're not, because I'm not attached to it. And that concludes the differences between the tool chains. Obviously, the Arduino is much easier, and the Microchip MP Lab is a lot more powerful, but there's a bigger learning curve there. And now on to the next section. Okay, again, we'll start with the Arduino. We'll go support, then dev boards, then on to Microchip. You can start out by going to arduino.cc to check out their website. This is where you'll find the downloads for the IDE, as well as the resources for the reference and some tutorials as well. If you check out the references, you can find out all the individual C-like or C-ish code does. And then you can also cruise over to the forum, and that's where you're going to find your support. Now, there's plenty of other resources, websites, tutorials, YouTube videos, tons of stuff out there for, if you need an issue, but this is the extent of the formal support for this product line. Looks like any other forum, really, even Microchip's forum. You ask a question, varying results on the answer. Moving into the store, this is where you get the officially supported dev kits. There's plenty of clones. There's a nice starter kit, a little expensive, but it's very nice. The Uno, which is the most popular board. The starter kit has a ton of sensors, a nice tutorial book, kind of get you started with the Uno in it. But again, there's a lot of other low-cost clones out on the market. Then into the Microchip PIC dev kits and products. There's more. There's a lot more, and it really depends on what your project is. Do you need USB? Is it motor control? Automotive? You have a lot of options, and they have a lot of resources on their website to go through and help you decide what microcontroller you need. And once you pick a microcontroller, you find a development kit that suits your needs. Besides some general guidance, they have some help on finding what kind of peripherals you need. Do you need a complementary waveform generator? What's that do? Do you need some CLC, configurable logic? That's some glue between things like A to D to PWM, so you don't have to run your microprocessor. They include also parametric search. The parametric search is probably the tool that I use the most. I go, and in this case I think I'm just going to select all microcontrollers. And then in that case I was complaining about the Arduino. I like a 12-bit A/D converter if I need it, so I'm going to go over to max ADC resolution. I'm going to select 12. Then it's going to refresh and give me all the microcontrollers that would work for my application. There are some AVRs and ATtinies in there, but mostly the PIC line. As you can tell, a lot of options for selecting it. In development tools, wow, the sky's the limit, really. I mean, there are a lot, between the different types of boards they have. You can look for some of the starter items, these 32-bit boards, but we are focused more on the 8-bit evaluation boards for this comparison. A variety of pricing too, from about $14 up to a couple $100. But pick one that kind of suits your needs. Do you need one for CAN or lighting? I picked one here that's a automotive one. When you order, it seems about everything you get, the pricing is pretty affordable. Seems like all the development boards come out of Thailand for some reason. But they usually come in a day or two, which is pretty nice. Selected another one here for a motor driver evaluation board. course, they have sample code and whatnot. So moving on to support, two types of support. Of course, they have the forums like the Arduino, but they also have additional support from field engineers. Now, you can usually pick up a field engineer on one of the social media networks like Twitter and get some help. Often field supports, for businesses that are buying large amounts of product, but you can find some support from them here and there. There's also decades of websites, blog posts, including my own blog, and a number of other support options, sample codes, walkthroughs, videos that you can find as well. So recap, Arduino, not as much support, but there is a lot and there's a huge user base, so you can usually find what you need on the more obvious simple items. Microchip, again, for a project that you have some specific needs, there's a lot more options and a lot more support for you. Now on to our final section, the integrated peripherals. And finally, onto our microcontroller peripherals. Okay, so microcontroller peripherals, why are these important? Well, it's hardware to complement your software, and the more that you can do in hardware, the less that you have to run your CPU to accomplish maybe potentially simple tasks. So if you have an analog to digital converter that can do all the conversion and maybe do some averaging, or even that information can make it over to like a PWM after that's done without CPU clocks, it just means more stuff that you can get done on your microcontroller, and you don't necessarily need to buy the next bigger one. So comparing peripherals in the PIC and the Arduino, again, this is difficult because we're talking about a microcontroller or a series of microcontrollers versus a development system, but I'm going to try to pick the data sheet for the Uno and Mega, and then a couple popular PIC mid-range 8-bit chips, which are somewhere in line with around the same, even though the PICs I selected are low pin count. So we're gonna cruise through this. I'm gonna give you a kind of a brief explanation of the different peripherals. All right, so they're both RISC and optimized for C. 32 megahertz on the 18326. It's got 4 8-bit timers, 3 16-bit timers, bunch of stuff most people don't care about brownout resets, power up timers, etc. They both have watchdog timers. The watchdog timer I don't see a lot of inside of the AVRs or in the Arduino IDE. I don't see a lot of use in them, which is fine. It's probably not needed in most cases. The PICs generally have a lot more peripherals, and this is where they really shine. These include the CLC, configurable logic cell. There's actually a COGS, or there's a type of CLC, not COGS, but within the Atmel line, but it's not implemented in this micro. There's complementary waveform generator. We'll go over that in a second. Compare capture, the PWM modules, numerically controlled oscillators, all the serial modules. DSM, which I think is pretty cool, data signal modulator. I'll go over that in a moment. Analog to digital converters, they both have that. Comparators, the PICs, a couple of them have the DACs. It's a 5-bit, but probably don't need much more unless you're going really high end. A number of them also have peripheral pin select, which is one of my favorite features. It's where you can do IO pin remapping. If you don't like, or it just doesn't work out for your serial to be on a certain pin, you can push it over to a number of other selected pins. There's many more timers on most of the PICs. On the 1619 over here, we also have an angular timer, which does some math based on angles. That's an interesting one. A math accelerator with built-in PID. It's got CRC or peripheral built in. And then some of these have DMA. I don't think either of these actually have DMA, but let's go through a couple of these items. We'll start with the summary of core independent peripherals, and this isn't all of them. I'm kind of surprised they're missing a couple here, but again, the angular timer, complementary output generator, event system, that's just in the AVRs. I don't think they have anything quite like that in the PIC, which is a -1. I didn't see that inside the spec sheet for the ATmega though. The numerically controlled oscillator, that's a pretty cool one. PWM modules, they both have that. Configurable logic cell. This is kind of like CP-LED, where it's a bit of logic. And I've seen where they actually used a CLC block to write a hardware driver for NeoPixels. So instead of implementing that in software and burning a ton of cycles generating 24-bit numbers for your NeoPixels, they've actually implemented the generation of the pattern in CLC. Complementary waveform generator. Who cares? Peripheral pin select, one of my favorites. Timers, they all have those CRC checks. That's nice if you're worried about data. Direct memory access. This is where one peripheral can directly share data into another one. A math accelerator is kind of neat. The temperature indicator, I've only seen that in some of the newer ones. It's where it has a on-chip sensor, and it can measure the temperature within the chip's specified ranges. So I think it's up to like 85°C. And then a watchdog timer. So the DSM, the data signal modulator, kind of neat. You know, you take two signals in and you create a modulated signal. It's for FSK, PSK. I would suspect that they use this in, well, actually they say it in LEDs, but they also use this in remote controls and that sort of thing. Then there's, as I mentioned, there's actually CCL for the AVR micros, or the CLC, kind of something similar. And as I'd mentioned, they've done a WS 2012 driver implementation video on how they did theirs. It was pretty interesting. CRC for data integrity. DMA, which is where hardware peripherals can actually send information over to other hardware peripherals, even when the CPUs are running in low power mode, which is pretty cool. One of the more interesting peripherals is this math accelerator, where it has 16-bit PID function built in. That's definitely worth looking at instead of running software if you can use it. The Angular timer is pretty interesting. It can convert time-based signals into degrees and a bunch of other things. Definitely a unique feature. And then there's some other similar items like the watchdog timer. As I mentioned, I don't see a lot of watchdog timer used often in the Arduinos, but there's a write-up here by Nicholas Larson worth taking a look at. You can just Google around for that one. Back into the into the data sheet for this ATmega. As I'd mentioned, 8-bit micro, just like the other ones, 131 instructions, which is more than most of the PICs. I don't know if that's a positive or negative. They kind of top out at 20 megahertz. Many of the PICs do 32 or 64. Blah, blah, blah. Who cares about how many flashes you can do? They both have capacitive touch support peripherals. There's 3 total timers that I count on these things. 6 PWM channels, which is common, or you can sometimes get more over in the PIC section. You know, UART, SPI, I2C, the watchdog timer, an analog on-chip comparator, which is a common feature in PICs as well. Interrupts on pin change, that's pretty common. And that's about it. There's nothing else that's really inspiring in this micro other than, you know, it's a decent, reliable, generic microcontroller. And as I mentioned, I don't think it's really fair to compare the two, but I do think the PICs on average have more peripheral features on the micros. All right, sorry for the audio difference in this section. Just finishing up the last bit and kids in the background, but such is life. So, PIC versus Arduino, not a fair comparison at all, to be honest with you. The Arduino, I use this in my Seattle Robotics Society's Robothon Pop Can Challenge competition. It's quick, easy, super easy to develop, one-off total. PIC. Use it whenever I'm developing my own boards. I need something really low power, battery power, that sort of thing. Really, it just depends on what your project is. What are you making? There's no real good answer, and nobody really can give you a great answer. Anyways, if I missed something and you have some great suggestions for reviewers, please put them in the comments below. I'm sure people appreciate that. Also, please consider subscribing. Thank you and have a nice day.